Hello, welcome back to video lesson number 2 on 7.3 exponential growth and decay modeling. So, a reminder, in our first lesson, um, we talked about the exponential function, a times b to the x, and how to write that with growth or decay modeling when you have an initial value, a sub 0, and the r, which again is a rate of growth or rate of decay, as a decimal form. Okay, so we did some examples of writing exponential functions given initial value and a growth rate or decay rate. So on the back of your handout there, example 3 and 4 and 5, it's going to be the same thing, although this time it's going to be the problems are going to be given to you as word problems, not just, so it's not going to just give you the initial value and the growth rate. You have to pick those out from the problem. All right, and that's how all the problems are going to look like from here, because as I said, these modeling problems are all real world examples. So I want you to get used to reading problems and picking out the important information. But remember, there's only two numbers that you need to look for. There's only two numbers we need. We need the initial value and the R, the growth rate or the decay rate. Okay, so look at example 3. The population of a city is 35,000 and it is increasing at a rate of 2.75% annually. Okay, so should be hopefully easy to pick out the important numbers. That's your initial value, and that's the growth rate. Since it's increasing, that's a rate of growth. So write an exponential function to model population after t years, excuse me. So A of t is going to be 35,000 times 1.0275 to the t. So just like we did in the previous video, you want to change this to a decimal. R is 0.0275, and then because it's growth, you add that to 1.0275. Now, use that model to find the population of the city in 8 years. So I simply want to plug in 8 for t, right? And this is where you will need a calculator, okay? If you don't have a graphing calculator, just any scientific calculator will work. Anything that can do exponential functions. So a calculator on your phone or on your computer, any of those will work. All right, so just plug in 8 for t, and you're going to have 35,000 times 1.0275 to the 8th power, okay? And plug that in the calculator and round to the nearest whole number, right? Because we're doing population. You can't have a fraction of a person. So round to the nearest whole number, you get 43,483, okay? And even though I wrote the answer down, please make sure, I want you to try that on your own. Make sure you get out your calculator and type that in just to make sure you know how to do that, okay? And if you didn't get that answer, try it again. And if you have problems with your calculator, obviously you can email me and I can let you know. I can answer your question. All right, part C now. Write the function if the population was decreasing. So let's make it decay instead of growth. So instead of adding this 0.0275 to 1, let's subtract it from 1. So that would be A of t equals 35,000. And then 1 minus 0.0275 is 0.9725 to the t. So if it was decay instead of growth, you would simply do 1 minus r. Okay? So your homework's going to have a lot of problems like that, where it just gives you in the situation with initial value and then a rate of growth or decay. Just make an exponential function to model it. Okay, now one way that we see exponential growth is in finance. If you put money in a savings account, if any of you have a savings account at a local bank, if you invest money in a savings account and it earns interest, that is exponential growth. Okay, and in some of the words we use are a little different in finance, and the variables might be a little different, but really the function is the same. So in finance, the initial amount you invest is called the principal, if you heard that word before. Like the initial amount of a loan or investment is the principal. So capital P, that's like the A sub 0, that's the initial amount. The R is the interest rate, A is the amount, T is the time. Now, the only difference is that with bank accounts, interest can grow with different compounding periods. This is called compound interest, if you've heard that phrase before. Compound interest is when you put money in an investment and every month or every quarter, every year you earn interest, it adds to your account, and then your balance is higher the next month, so you earn a little bit more interest. It keeps growing like that exponentially. So in this problem, the end of the problem is the number of times per year that interest is compounded. The number of times per year that interest is compounded. All right. So in the problem, let me pause for a second here. Okay, we're back. So one more time. You will be given this in the problem. It will tell you interest is compounded annually or quarterly or monthly or daily, and you just have to know what those words mean, right? Um, Annually means once a year, monthly means 12 times a year, quarterly is 4 times a year, daily would be 365 times per year. Okay, so if you look at this formula, notice it looks very similar to what we were doing above. You've got the initial value, a sub 0 or p, and then before it was 1 plus r to the t. Now, with this n, you're doing two things. You're taking r dividing by n, and you're taking your t and multiplying it by n. All right, so it's the same thing we did on the previous video, 1 plus r to the t, just with this n in the problem, in the formula in two different spots. Okay, now, sometimes you have what's called continuously compounding interest, which is just like it sounds. Interest is compounding continuously. Now, I'm not going to get into all the details about that, but when we see that, we use this other formula, PERT, P-E to the R-T, okay? And this number E, I mentioned it in the previous video. This E is the base of the natural logarithm. Anytime we do exponential growth, then this number E comes up a lot. It's like pi, it's an irrational number, okay? So P times E to the RT. Whenever you see this word right here, continuously compound interest, you use PERT. So let's do example 4, 3 different cases here. For this problem, your your P, your R, and your T will all be the same. The only thing that's different is the N. So find the amount present after 6 years if you invest $12,000 at 2.8% for different compounding periods. Bank A is going to be compounded annually, part B will be compounded monthly, and part C will be compounded continuously. Okay, so let's see. The 6 is my T, right? That's the time. The 12,000 is your initial amount invested, that's the P. And then the 2.8% is your R, that's the rate of growth, right? So what does annually mean? Annually means once a year, so N is 12. Monthly, well, there are obviously 12 months in a year, so N is 12. And then compounded continuously is when you use this other formula, the PERT. Okay, so let's write this out here. If I want to find annually, A is going to be 12,000 times 1 plus 0.028 divided by 1. I really don't need to divide it by 1. And then raised to the 1 times 6, which is just 6. Okay, so annual growth rate really is the exact same as what we did above, right? Because if n is 1, you don't really need the n, you just have 1 plus r to the t again. Okay, now, what if we have a compounded monthly? Okay, well, that's going to be 12,000 times 1 plus 0.028 divided by 12. So you take the r divided by 12, but then the exponent will be 12 times 6. So again, the n goes two places, r divided by n and n times t. And then lastly, compounding continuously. You're going to be your PERT formula. So 12,000 times e raised to the 0.028 times 6. Okay, so you can type those 3 in your calculator and compare the answers. But before you type it in, I want you to think about it. Think about these 3 cases. Which one do you think will give you the most money when you're done? Compounded annually, compounded monthly, or compounded continuously? So ask yourself that first. Which one's going to give you the most money? And do you think it'll be a large difference or a small difference? Okay, and then I'll give you a moment to type those in your calculator. So pause the video, do that, and come back and check your answers with me. Okay, and when you're back, let's see the answers. Compound annually, the value is 14,162.50. Right? Since this is money, we're going to round to the nearest cent. Compound monthly is going to be 14,192.46, and compound continuously is 14,195.24. Okay, so if your guess was the more often the interest compounds, the more money you will have in the end, then yes, you were correct. Compound monthly gives you more money than annually, and compound continuously gives you more money than compound monthly. But if you notice, it's not a lot more, right? The difference between here is $30. That's a decent amount, but the difference between here is $3. That's not very much at all. So the point is, even though it's compounded more frequently, the amount you're earning each time is smaller, so it's going to give you a little bit more, but not a large difference. All right. Now the last example, and then you can try some assignments on your own. Okay. Example 5, solving for the principal. Okay. Go back up to here. Suppose instead of giving the P and finding the A, suppose you know the A and you want to find the P. In other words, you know how much you want to have in the future, and you need to ask yourself, how much should I invest now to have that in the future? Okay, I'm back. I had to break from tell my children to be quiet while I'm teaching here. Anyways, to finish this last example, you're solving for the principal. So you know the future amount, you know the A, and you want to find the P. So let's read the problem. How much should be deposited in a 3-year CD? CD stands for certificate deposit. It's like a savings account, which will earn 2.25% compounded continuously if you want the CD to be worth $7,500 when it matures in 3 years. Matures is when the CD is up and you get your money back. So since it says compounded continuously, we're going to use this equation right here. A equals P times e to the RT. All right. Okay, so let's write down what we have. The A is 7,500. That's the future amount. That's how much we want to have in 3 years. All right. So our T is 3, and our rate is 2.25% or 0.0225. Okay, so plug that in the PERT formula and solve for P. So you have 7,500 equals P times E raised to the 0.0225 times 3. Okay, and you can do this in your calculator, e to the 0.0225 times 3, and you get 1.06983. Okay, you get more decimals than that, but if you round it, let me zoom in so you can see that better. All right, you get more decimals than that, but you round it there. Now, let me take a moment to talk about rounding. Okay, do not round until the very end. Okay, now you'll need to round somewhere, but leave plenty of decimal places here. For example, don't put just 1.06 or 1.07. Okay, because when you divide here, this answer will be off. So you want to leave as many decimal places as you can in the middle of a problem. Round when you're done. Okay, so to solve for P, then I'm going to do 7,500 divided by this number. Okay, and you get approximately $7,010.46. So 7010.46. Okay, so that's how much you need to invest to reach 7,500 in 3 years. All right, so after you finish going through those examples, then there's a homework sheet that I posted online for you to try. Okay, so let me just kind of walk you through these here real quick. The first 4 are like the example that we did in the first video, where it gives you the function. Just simply say, is it growth or decay, and find the R. Okay, and then we get into a bunch of word problems having to do with modeling exponential growth and decay. All right. Now, let me just warn you here. Be careful with the units. Okay. So, for example, in number 8, it's 3% every year. Find out how much it'll be in 9 years. Okay, that's good. But make sure that the rate matches the time. Okay, so for number 9, this 80% is every hour. Okay, then I asked 3 questions. How much will there be in 5 hours, in 1 day, and in 1 week? Make sure you change 1 day and 1 week to hours. The units have to match up. Just like number 10, the growth rate is 2% each month. How many will there be in half a year? What will be in 10 years? Again, since it's 2% each month, make sure that your time is in months. Okay, and then the last 3, 11, 12, and 13, all use one of the finance equations, the growth, the compound interest formulas, or the either continuous compound interest or compound n times per year. Okay, so after you watch these videos, try the homework number 1, and then email that to me when you're done. If you have any questions, of course, let me know.